Recent discoveries in the study of gravitational waves have gotten many scientists and astrologists excited at the possible implications this phenomenon will have on the knowledge of the known universe. These newly detected waves could change our theories on the events after the Big Bang and might even prove the existence of certain controversial cosmic phenomena. Today on Super Freaky Science, we'll be looking at gravitational waves from the beginning of time. Let's ride! What are gravitational waves? Gravitational waves were a cosmic phenomena with very little evidence to prove their existence besides mathematical formulas. However, recent studies and imaging have proven them to be just as real as gravity itself. These waves are disturbances in the fabric of space-time, caused by massive objects orbiting at astronomical speeds, sending waves outward moving at the speed of light. Their existence was predicted by Sir Albert Einstein, drawing the basis from his theory of relativity. Massive cosmic bodies like planets distort space-time around them in the same way a bowling ball distorts the surface of a trampoline when dropped on it. The general theory is that the bigger the object, the more space-time it distorts, and vice versa. For instance, if a golf ball were placed on the same trampoline in the middle of a circle and made to circle the bowling ball, the small golf ball would fall inwards into the distorted section of the trampoline. This is the same way a rock circles a planet, or the way our moon circles the Earth. These gravitational waves, on the other hand, travel outwards from an object as it revolves and moves in space, only these waves travel much faster than the object that produces them. They travel at the speed of light. The basic concept regarding gravitational waves in space is that they are produced when two objects of astronomical size revolve around each other, each propagating its own gravitational waves as it moves closer to the other object. In the known universe, scientists believe gravitational waves are produced when two cosmic objects orbit each other in binary pairs. They could either be a neutron star and a black hole, two black holes, or two neutron stars revolving around each other in binary pairs. The orbiting interaction between these two cosmic objects causes the resulting distortion in space-time, which produces ripples throughout the universe and can be picked up by instruments here on Earth. When were they discovered? The first ever gravitational wave to be detected was picked up by the LIGO Observatory in 2015. The Laser Infometer Gravitational Wave Observatory, or LIGO, is a physics observatory experiment building to detect gravitational waves traveling through the cosmos. LIGO detected gravitational waves produced from the collision of two black holes 30 times the mass of the Sun at a distance of 1.3 billion light-years away from Earth. In October of 2017, the LIGO, alongside the Virgo Observatory in Italy, which is a collaboration between the National Centre for Scientific Research (CNRS) in France and Italy's National Institute for Nuclear Physics (INFN), detected the first ever gravitational wave produced by a binary neutron star. The mass of the neutron star was about 1.7 and 1.6 times the mass of our Sun, and the resulting solar mass after the collision was about 2.8 solar masses. Because the neutron star were different from black holes, they also emitted gamma rays during the collision, which were picked up by several other observatories around the world. LIGO and Virgo, as well as other observatories being designed around the world, have proven the existence of gravitational waves by detecting current events billions of light-years away. These instruments have been picking up gravitational wave signals so frequently that their existence can no longer be disputed. They have helped us shape our understanding of how black holes and neutron stars increase in size, as well as what kinds of particles they are made of. But a new discovery might have just picked a wave signal older than all of the rest. Two new signals picked up by a gravitational wave detector have been named the strangest gravitational waves scientists have ever discovered and could hold the key to some of the less understood parts of the universe. These wave signals are so different from previously detected gravitational waves that scientists believe they might have originated from an older time. The waves are believed to be so old that they are said to have originated from the birth of the universe. That's right, gravitational waves were produced during the Big Bang. Gravitational waves after the Big Bang. The Big Bang is still the #1 scientific explanation for the creation of the universe. However, it still remains a theory based on mathematical formulas rather than actual facts. And because scientists currently don't have the equipment to look back in time, what they can do is measure certain phenomena such as the echoes or vibrations that have been reverberating for over 13 billion years. Scientists use their current equipment to measure what's known as cosmic microwave background, or CMB. To understand what CMB is and how scientists can measure it, we need to take a trip back to the beginning of time and the birth of the universe, the Big Bang. In its simplest form, the Big Bang states that around 13.8 billion years ago, the universe as we know it was an infinitesimally hot and dense singularity. And then, boom, the Big Bang. An expansive explosion of immeasurable proportions stretching out our universe at speeds faster than the speed of light occurred. This period of cosmic inflation was so fast, it lasted only a mere fraction of a second, giving rise to the next phase of creation. The amount of energy released during this cosmic inflation is beyond any measurable scale, but as powerful as it was, it came to an end almost as fast as it began. Then followed a period scientists termed the period of reheating, which involved a flood of matter and cosmic radiation that started creating and populating the young universe with the most basic forms of atoms and particles. This was still all happening within the very first seconds of the Big Bang, when the universe was still unbelievably hot, which according to NASA exceeds 10 billion degrees Fahrenheit in temperature. This temperature, of course, was just the right amount needed to cook the cosmic soup that gave rise to neutrons, electrons, and protons, which make up the basic parts of every object in the known universe. This heat left over from the heating period is what is known today as cosmic microwave background and lasted for about 400,000 years after the Big Bang. After this time period, the early universe became too cold and bright for CBM to be visible to the naked eye. So when scientists map CBM today, they are taking a look back in time to the earliest period of the universe right after the Big Bang. This early period of the universe where atoms and matter began to form would have astronomical amounts of gravitational waves as the newly formed matter orbited one another at incredible speeds. These waves have distorted the fabric of space-time and the CMB as well, leaving a sort of activity log on the CMB after it cooled off. So these newly detected waves, coupled with our knowledge of cosmic microwave background, could hold the key to studying the universe at a point in its existence never before seen. These studies could not only help us to see into the past, but could also prove the existence of other mysterious cosmic forces such as dark matter, antimatter, and dark energy. It could also give more precise parameters on atom density, the universe's rate of heating and expansion, and other cosmic phenomena. The discovery of gravitational waves has already changed previously known facts, such as the actual age of the universe, which was thought to be 13.7 billion years, but has now been adjusted to 13.8 billion years. Also, other cosmic facts such as when the first stars began to shine have now been put at 200 million years after the Big Bang, much earlier than previously thought. More facts and myths will be proven or disproven in the coming years as scientists make more strides in studying gravitational waves, and we simply can't wait for it.